start with, I'm really honored to be here with all of you, fellow space geeks and pioneers. So I think our aspirations as a species, and I think not just for us, for humans, but all the other cohabitants of this planet, is towards freedom, to maximize freedom and maximize options. And a while back it started with fish walking out of water, and for us it's also connected to like tools we make, like the humble cell phone and its evolution. And at some point we had lizards, insects going to another medium, or going to air, spending most of their time, or a big chunk of the time, in the air. And now we have humans essentially using the tech we built to go back to the ocean, under it, over it, air, and now even space. And this is all tied to our ability to advance technology. And one of the key technological innovations of the day is the humble smartphone, which hopefully is helping us, not the other way around. But we're about to really let down smartphones, because on Earth we're running out of a lot of the critical materials we need to make these things, especially as they get more advanced. Not just smartphones, but most of our advanced tech. So my question is, can anyone recognize what this is up here? Anyone?
Lithium mining?
So this is a tailings dam associated with mining rare earth minerals. This is something that happened last year. And these things are supposed to be stable for 10,000 years. They're human-made constructions, right? That should work for 10,000 years. So I guess we kind of better call the Egyptians, because last year and many times these dams rupture and they pollute the environment. They release arsenic and cyanide and a lot of other bad things into our environment. So on one hand, we kind of need these things a lot, but on the other hand, it's not doing great. So you're going to say, but Cezar, we can mine the oceans now. You know what this is, right? These are essentially just sitting there on the bottom of the ocean, just waiting for us to pick them up. Manganese nodules, they have like a lot of the critical materials we need for our technology. But the issue is that if we do start picking them up, kind of like this, we're going to get to a point, or we may get to a point, where we kind of turn the oceans purple, because these things are actually batteries connected in series on the bottom of the ocean, and they're creating oxygen. So what I'm trying to get here is that a lot of the things we do on Earth are directly impacting our supply chain. When I say supply chain, I mean, wheat, the basic stuff, the stuff that keeps us alive. So not just the advanced things we learn and play with. So we're kind of here, and we have two major options. One, we think of all the solutions and we kind of apply local solution to things, regulations, innovation on Earth. Or we think of what we can do in the solar system to fix these problems. So I kind of try to collate the most critical problems we have as a species in the next few decades, and one of them is climate and ecosystem collapse, like ecosystem collapse that's related to climate change. And we're not really doing very well on the regulatory aspects, right? Because everyone wants a cell phone, everyone wants a car. Why shouldn't people in India have the same luxury that we have here? And on Earth, you could say, well, okay, all these methodologies failed. We can always do geoengineering. We can put aerosols in the atmosphere, change the albedo, make the ocean shinier. Problem is, that's not really a solution you want to do, because it's hard to, it has a lot of inertia, it's expensive, and it's hard to change. So what we could do we could put mirrors in orbit that are tunable. We have like fine tuning to change the albedo and keep going, growing potatoes. Then we're looking at the energy crisis, right? We're seeing it unfold live on TV, right? Iran produces, what, 30% of some parties' oil, leads to frictions. You'd say, well, we can all go nuclear, but the thing is, reserves of uranium and thorium, they're also limited. So it's a solution, but it's a temporary solution. So what you could do is you go for space-based solar, and what do you know? Tunable orbital mirrors, space-based solar, there's a bit of a connection there. Then we can look at the critical minerals shortage that I mentioned earlier. So one option is to make more mines, right? There's a lot of reserves, but the problem is these dams, they need to be stable for a long time. They're not going to be, I promise you. I've seen personally some of the sites around the world where these things failed, and they're still not recovered after like 30 years. These places are wastelands. So what we could have lunar refineries. We could make the moon the supply chain hub of the solar system. We can source resources from the solar system, and we can send to Earth 99.99999 purity materials to be used. And then a really, really big problem is we will eventually run out of places to do selfies, and a lot of you would say, well, Cezar, we have metaverse, but have you really seen the avatars there? Like, you don't want to stay there, you're gonna get depressed. So what about trips to the rings of Saturn, you know, as an option? And this, I mean, I was about to say this isn't really rocket science, for now it's rocket science, but it's doable. We could get materials from near-Earth asteroid, platinum group materials, refined on the moon, sent to Earth, and that's going to be a solution for a lot of problems. Imagine cheap fuel cells. We get aluminum lowered. We get platinum lower than the price of aluminum. We get to a point where the hydrogen economy starts to actually make sense. We can send materials in orbit for manufacturing. This could be the moon has plenty of silica. This could be the thing that actually feeds space-based solar. As Broge was saying earlier, it's much cheaper from an energy and economical perspective to send things from the moon to Earth than the other way around, than from Earth to orbit. So mass riders on the moon and manufacturing hub there, we're going to be making so much money. Then later on, the same mirror arrays that we use to kind of fix the atmosphere here, well, we can use that on Venus. We can actually freeze Venus in about 400 years if we block enough sun. We use Venus. It's a great planet that has 1G just like Earth. So if you want to go on a holiday, that's the place where you want to be, like on an extended holiday. And we can send materials back to the moon from Venus, mass drive it. We have that frozen CO2 chunks, you know, they can be their own fuel source. They can anywhere in the solar system. We then, you know, start including Mars, but this time we use the solar mirrors not to block the sun, but to increase the insolation. We can use some of that CO2 from Venus to actually have a nice atmosphere on Mars, because pressure suits are fun but you don't want to live in a pressure suit. And this can be our future, where we're not worried about jobs getting replaced by AI. We're worried about there's not enough people to actually fill the jobs. If you've been to the space com yesterday, you might have noticed the immense diversity of suppliers just for the tiny industrial base we have in space right now. Imagine this magnitude. where you're going to be more worried that the barber is free on the moon than how much oxygen you have available. So I think I'm super optimistic, and I think we're going to make a lot of shareholder value through investing in space and actually doing it. And as changes of medium happen to bring more opportunities, I think the change of medium is also going to change us. So I think the biggest challenge in the future is actually going to be morality, education, and ensuring that we still stay one human species united as we expand into the solar system. And education and opportunities are part of that, the same space. So, yeah. Thank you so much.